Today we are moving to another important topic in chart work, and that is the concept of position circles. I have already discussed with you the concept of position lines. We saw different methods with which position lines can be obtained and plotted on the chart. Now we are going to do that same thing with position circles. So we will see different methods with which position circles can be obtained, or they can be given to us in MMD questions, and how do we plot them on the chart. Every different case or method, how do we plot that position circle on the chart? For a position line, we needed to know a position from where the PL passes and the direction of the PL. For a position circle, we require the center of the circle and the radius of the circle. So these are the two items which are required for a position circle. So we will see what are the different methods, and in each of these methods, how do we get the information required for plotting and how do we plot them. So this is all what we are going to do now. We may not be able to complete it today, but there are many methods with which position circle can be obtained. So whatever is possible today will be done, and then we will continue in the next session. Now, many of these methods which we are going to discuss now, they are not practically used on board nowadays. We will be doing HSA, that is horizontal sextant angle. We will be doing VSA, that is vertical sextant angle. We will do high altitude observations. So all these methods are practically not very much in use. So why are we discussing them? The purpose is, number one, passing in the exams, because many of the questions of chart work are involving these position circle concepts. And number two, if we have a emergency situation scenario on board, the GPS fails. So in that case, if you are coasting, then all these methods may come in handy as a sort of backup navigation or emergency navigation. So that's the entire purpose. So shall we move on to position circles now?
Yes, sir.
Yes, sir.
Okay, good. So just give me a moment. I will set up the video.
In this video, we shall try and understand the concept of position circles and the various methods that could be deployed in chart work to obtain position circles. Having understood the concept of position lines in the previous video, now let's understand what a position circle means and how we could draw position circles on the chart. A position circle is any circle, the arc of which passes through the observer's position. If we can obtain a position circle, it shall mean the observer is located somewhere on the circumference of the circle. A unique position circle can be drawn on the chart only if we know its center and its radius. Basically, the purpose of all the methods shall be to identify the center of the circle and also to obtain its radius. We usually draw only a small arc of the circle as per our requirement in the vicinity of the vessel, and not the full circle to avoid cluttering of the chart.
Okay, so you see, beta, basically if we want to plot a position circle on the chart, the two data items which we are interested in is what is its center and what is the radius. If we know these two things, it will be easy for us to plot that circle on the chart. So every method for position circle gives us the center as well as the radius.
draw only a small arc of the circle as per our requirement in the vicinity of the vessel and not the full circle to avoid cluttering of the chart. Now, various methods for obtaining position circles include position circle by radar ranges, position circle by vertical angles, by horizontal angles, by raising or first sighting and dipping or last sighting of the lights, and position circles by high altitude celestial observations. Now we shall try and understand each one of them separately. Position circle by radar range. The distance of the conspicuous landmark identified on the chart is measured by radar and referred to as radar range. The position circle is then drawn on the chart with the position of the object as the center and the radar range as its radius. Let's try and look through it with a simple example. At 2000 hours, radar range of Ballycotton Island light was 5 miles. Draw the 2000 hours position circle.
Okay, so we are starting with the most basic position circle beta. This is too basic. You have done it in second mates as well as in pre-C, but just covering up all the aspects so that nothing is left.
So first and foremost, let us identify Ballycotton Island light on the chart. You can see this one is the Ballycotton Island light on the chart. Now with this light as center and 5 nautical miles as the radius opened on the compass using the latitude scale of the chart, we draw a circle on the chart. So the position circle is drawn here with 5-mile radius and Ballycotton Island light as the center. And this becomes the position circle of the vessel at 2000 hours. Now we move on to position circle by vertical angle.
Okay, now this is the second method beta, position circle by vertical angle. So this method, as I told you before, that is practically not used nowadays. So it was used in the olden days when ship size were a little smaller and the safe distances from shore were lesser as compared to what we have today. So that means vessel will be going closer to a lighthouse and the lighthouse would be appearing significantly bigger so that we can take a vertical angle of the lighthouse. Vertical angle basically means finding out what is the angle between the sea level and the top of a lighthouse. So that is known as vertical angle. We used to take it in the olden days using a sextant. So let's see how do we get a position circle if we have the vertical angle of a object like a lighthouse.
Sir, I have one doubt, sir. How will you determine the center of the lighthouse exactly?
Center of the lighthouse, beta?
Yes, sir, for drawing the circle.
Okay, let me show you a light on the chart. Just give me a minute. Screen now?
Yes, sir.
Okay, I have a lighthouse here. Let me zoom in a little bit. You can see this hook headlight.
Yes, sir.
So we have a circle, we have a star, and we have a loom. So the center or the location where this lighthouse is exactly where the star is.
Yes, sir.
Okay, sir.
Okay, beta, understood?
Understood. Thank you, sir.
So even though if there is no circle around it, because a circle would be there on a reckon, so you could have a lighthouse without a circle, like you see this one. That's the pilot lookout light. So here there is no circle, but you can see the star. So the center of the star is where the exact position of the lighthouse is.
Okay, understood, sir.
Okay, this was what you were asking, na?
Correct, sir. This one I am asking.
Okay, beta. Okay, good. Let's go back now.
The vertical angle subtended by an object at the observer depends on the height of the object and the range of the observer or the distance of the observer from the object. The vertical angle on the ship is measured by sextant and hence referred to as vertical sextant angle. The charted heights are given with reference to mean high water spring. If charted heights of the objects are used, they must be corrected for the tidal variance with respect to mean high water spring to obtain their height above sea level at the time of observation. Range of the observer is then calculated using this formula. It's 1.854 into height of the object in meters divided by vertical angle in minutes. Please remember, the range so obtained shall be range in nautical miles. So please be careful about the units. The range shall come in nautical miles, height of the object is in meters, and vertical angle is in minutes, not degrees and minutes. Height of the object above sea level would be the charted height plus minus the tidal variance with respect to mean high water spring. And vertical angle is equal to the vertical sextant angle corrected for the index error of the sextant. Index error, if it's off, then it's added, and index error on the arc is subtracted.
Okay, so let's understand all these things one by one, beta. The first thing is that the vertical angle subtended by any object depends upon two things. One, it depends upon what is the height of the object, and second, it depends upon what is the range of the observer from the object. We measure this vertical angle using a sextant, so we sometimes call it vertical angle, or it can be called vertical sextant angle, in short VSA. Now, to find out our range from the object, we use this particular formula. Now, in this formula, we need to know what is the height of the lighthouse. So how do we obtain this height of the lighthouse? Let me show you on the chart. Let's go back to the lighthouse which we saw. So beta, we have the lighthouse. Can you tell me what is the height of this particular light, hook head light?
46 meters.
46.
Very good. And what is this with capital M?
So miles.
The visibility, sir. Visibility.
Very
Range.
Luminous range.
Very good.
Nominal.
Very good. So the figure which is given here along with small m, it gives us the height of the lighthouse. So it is 46 meters height. And the figure which is given with capital M, it is the nominal range of the light. We will discuss about what is nominal range later on, so it will come. So for now, we can read off the height of the light from the chart. So it will be given on the chart, it can be picked up. Now beta, I have one doubt in my mind. The doubt is that sea level keeps on changing. Because of the tidal flow, the level of the sea keeps on changing. At the time of high tide, the sea level which will be much higher, and at the time of low tide, the sea level will be much lower. So अगर हमारा sea level change होगा तो ये जो height है ये तो change होती रहेगी, right? So how is this 46 meters fixed height calculated?
सर LHT पे निकालते हैं सर.
Sea level.
Mean high
Okay,
water.
okay, all right. राइट सो हमें दो तीन चीजें यहाँ पे सुनाई दी. वन वाज LAT, that is the lowest astronomical tide. Other was MHWS, that is mean high water springs. So बेटा ये जो heights दे रखी हैं लाइट्स की, जो भी हाइट्स हमें चार्ट पे दी हुई हैं, they are given with reference to mean high water springs. Okay, so what is this mean high water springs? Springs हाई वाटर के टाइम पे जो भी टाइडल हाइट होती है, अगर उसका मीन ले लिया जाए ओवर द ईयर, so that figure is called as MHWS. You don't need to go into detail. What we need to remember here is कि ये जो 46 meters की height है, this 46 meter height is applicable if the sea level is at mean high water springs. अगर सी लेवल मीन हाई वाटर स्प्रिंग्स के ऊपर है या नीचे है, तो हमारे लाइट हाउस की हाइट जो है वो चेंज हो जाएगी. लेट मी गिव यू एन एग्जांपल. लेट अस से जो हमारा एक्चुअल सी लेवल है वो मीन हाई वाटर स्प्रिंग से 2 मीटर नीचे है. एक्चुअल सी लेवल इज 2 meters below mean high water springs. Can you tell me what will be the lighthouse?
48 meter.
Okay, very good beta. So if the sea level is less than or below mean high water springs, तो obviously जो lighthouse की height है वो बढ़ जाएगी. So it will be 46 plus 2, that is 48 meters. And if the height of the sea level is above mean high water springs, let us say it is 2 meter above mean high water springs, then what will happen?
44.
Very good. Very good beta. Very good. So this is something which usually does not happen. Mean high water spring के ऊपर sea level बहुत rarely जाता है, but if it goes, then you know the height of the light will be lesser than what is written on the chart. So as far as chart work is concerned, तो हमें क्वेश्चन में जहाँ कहीं भी इस हाइट को यूज़ करना होगा, they will tell us what is the actual sea level at that particular time of observation. So हमें बताएंगे कि जो current sea level है that is so many meters above or below mean high water springs, and उसको यूज़ करके हम लाइट हाउस की जो प्रेजेंट हाइट है, एक्चुअल हाइट है, उसका पता लगा लेंगे. So any doubt up to here beta?
No, sir.
Very good. Let's go back to the slide. Okay. So this is what is given in this particular point beta. The charted heights are given with reference to mean high water springs. If charted heights are used, it must be corrected for tidal variance with respect to mean high water springs to obtain the height above sea level at the time of observation. Now comes the important thing. So ये formula बेटा आपने note करना है. You want, you can take a screenshot of the slide and note later on. But इस formula को बेटा अपनी notebooks में अच्छे से note कर लो और highlight कर लो. You need to memorize this formula. Now, important thing to know in this formula is it has been made very much user friendly. How? The range which we need should be in nautical miles. So that's exactly the unit of the range which we will get by using this particular formula. So because we need to plot it on the chart, so ये जो range है इस formula से हमें nautical miles में directly मिलेगी. 1.854 is the factor which we are using. Height is the height of the object above the sea level, and this height is in meters. हमारे जितने भी चार्ट हैं जो फेज 1 एग्जाम में आते हैं, all these charts are on meters, so you will not find feet anywhere. So the height which we input in the formula is the height in meters only. Then the vertical angle which we have to input in the formula is in minutes. Why has it been given in minutes? Usually angle is denoted in degrees and minutes, but the vertical angle in this particular case will never go in degrees. So normal cases, when you are in a normal scenario far away from the lighthouse, it will be always in minutes. It will never go in degrees. If it is in degrees, then you are in danger somewhere. You are too close to the land. Either the vessel is going to run into danger or you are aground already. So that's why they have kept the vertical angle in minutes only. So we need to be careful with the units. If this vertical angle is given to us as a sextant angle, that is vertical sextant angle, then we know that every sextant has a instrument error which is called as index error. So if we measure the angle by a sextant, then that instrument error has to be applied. So how do we apply that instrument error? It's very simple. Consider it like a light switch. अगर वो ऑफ हो तो आपने उसे ऑन कर देना है. ऑन करने का मतलब है पॉजिटिव. और अगर वो ऑन हो तो आपने उसे ऑफ कर देना है. ऑफ करने का मतलब है नेगेटिव. So if the index error is off or off the arc, it is to be applied as positive, and if the index error is on or on the arc, it is to be applied as negative. So this is the full explanation of vertical sextant angle. Now have a good look beta at the slide, at the formula. Let me know any doubt coming in your mind. Very good. So if I give you a lighthouse and I tell you its vertical angle, can you give me the range?
Yes.
Yes, sir.
Okay. Very good. ठीक है बेटा. So this is the vertical sextant angle method. So let's proceed further now.
Let's learn drawing of a position circle by vertical angle through this simple example. At 1100 hours, vertical sextant angle of Ballycotton Island at ship was observed to be 0 degrees 18 minutes. Index error 2 minutes off the arc. At that instant, the tide was 1 meter below mean high water spring. Draw the 1100 hour position circle by vertical angle. So first and foremost,
Okay, just note down these figures in your notebook beta. We will calculate and see if we get the right answer. The vertical sextant angle is 0 degree 18 minutes. Index error is 2 minutes off the arc. And the tide is 1 meter below MHWS. Let's proceed ahead.
we identify the Ballycotton Island light, and this one is the Ballycotton Island light. You can see here where we have a box around it. So this is the Ballycotton Island light. Now we calculate the range using the formula that we have learned earlier. Now for that, we need the height of the object and we need the vertical angle. So we first, from the chart, pick up the characteristics or read of the characteristics of Ballycotton Island light. So the characteristics of Ballycotton Island light are.
Okay, so we can see the characteristics of the light on the screen now. So can you tell me what is the height of this light, beta?
The light in 59. 59. 59.
Very good. So that's 59 meters. Now the tide is 1 meter below MHWS. So what will be the height which we will use?
60.
Very good. Very good, beta. So we will be using 60 meters height. So can you tell me now, beta, with this height of the lighthouse, the angle is 0 degree 18 minutes. The index error is also with you. Can you just punch in these numbers and give me the range?
5.56.
Okay, so 5.56, huh?
Yes, sir.
Everyone got it, beta? Anybody struggling?
Yes, sir. 5.
सर एग्जाम में ऐसे ही क्वेश्चन आने चाहिए.
ओके, क्वेश्चन तो बेटा ऐसे ही आएंगे. बस ये है कि अभी हम ब्रिक बाय ब्रिक कॉन्सेप्ट को स्ट्रेंथन कर रहे हैं. एग्जाम में आपको सीधा वहां पे घर दिखाई देगा. सो दैट इज द ओनली डिफरेंस. बट वंस द कॉन्सेप्ट्स आर क्लियर इन योर माइंड, देन देयर इज नो वरी. So let's proceed ahead.
Flashing white red in seconds, 59 meters, 22/18 nautical miles on for 90 seconds. What we are currently going to focus upon is 59 small m, which is the charted height of the light. So please remember, in the characteristics of the light, the figure with small m is the charted height. So in this case, the height of the Ballycotton Island is 59 meters. Charted height is 59 meters. Height of the tide given in the question is 1 meter below mean high water spring, which makes the height of the object at the time of observation as 60 meters. Vertical sextant angle is given as 0 degrees 18 minutes. Index error is provided as 2 minutes of the arc. So the vertical angle is 0 degrees 20 minutes, which when converted to minutes, it is 20 minutes. Now using these values, we can put them in the formula and we can get the range of the observer at the time of making this observation. And the range of the observer comes to 5.6 nautical miles.
Okay, now beta, whenever we calculate ranges in our chart work, so usually we round them off to one place after the decimal, because this is the accuracy which we use in our chart. So in the calculator you may get even more accurate values, like you all were getting 5.56. We round it off to one place after the decimal. So that's why you see the figure 5.6.
ये जो फॉर्मूला है ये कैसे मिला वो?
Okay, we can go into that also, beta, but I will not go it right now. It is nothing but simple trigonometry. Okay, if you see, one of the component is the height of the lighthouse. Other component is the vertical angle that is happening at the eye of the observer. And the third component is the range, right? So it's simple trigonometry derivation. So, but I'm not going to go into it because what we are bothered about is the application of the formula. Did you get it, beta?
Yes sir. Okay.
Okay. Okay.
सर एक डाउट है, इससे रिलेटेड नहीं है तो ये
बोलो बेटा.
पीछे लाइट का जो स्पेसिफिकेशन था ना, उसमें 18/22 था, आई थिंक, जो भी था वो.
Okay, okay. Let me go back. I'll show you again. Here it is.
Yes sir, 22/18 miles ना, तो उसका क्या
Right.
मतलब है सर, कैसे डिनोट करा है?
Okay, can anybody tell, beta? Anybody knows?
Two lights की characteristics are white and red.
White is 22 and red is 18.
Okay, all right. Let's go to the chart. I'll show you better. This is belly cotton island light. Let me take you to the chart. This is hook head. Let's go to belly cotton.
लाइट सेक्टर की विजिबिलिटी तो नहीं है।
Okay, so we are beta belly cotton light. Can you see on the chart now?
Yes, sir.
Okay. अब देखो बेटा, it is a sector light. Can you see this white sector here?
Yes, sir.
So you have a white sector in this region. Then there is a red sector also. Okay, ये देखो यहाँ पे है बेटा इसका red sector. So you see in the description of the light, it is flashing white red. When you are in the white sector, the light will appear white to you. When you are in the red sector, the light will obviously appear red to you. These two ranges correspond to these two colors. Range for the white light is 22 miles. Range for the red light is 18 miles.
Okay, sir. ठीक है.
सर ये
Okay.
एक और आर्ट लिखा हुआ है, इसका मतलब रेड व्हाइट दोनों एक तरफ नहीं दिख रही।
कहाँ पे है बेटा R?
ये लिखा है।
Are you talking about this one?
यस सर।
Beta, this is a okay.
सर ये सीट बेल्ट के बारे में बता रहा है ना?
Yes.
रॉकी
बेटा,
सीट बेल्ट।
ओके सर।
ये पिछले लेक्चर में डिस्कस किया था हमने. This is the nature of the seabed. ये देखो एक रेड लाइट यहाँ भी आ गई ना.
हाँ जी सर, सेक्टर लाइट्स हैं सर, ये तो व्हाइट दिखेगा, रेड दिखेगा।
सर ये अभी इस पे चल रहा तो ये भी बता दो. हॉर्न फॉर 90 सेकंड, मतलब 4 हॉर्न बजेंगे विद इन 90 सेकंड, करेक्ट सर?
Yeah, four horns will be repeated every 90 seconds.
सर उसकी ड्यूरेशन नहीं बताई ना इसमें कि कैसे बजेंगे या क्या प्रोसीजर है उसका कि आफ्टर.
ओके बेटा, वो आपको लिस्ट ऑफ लाइट में पता चल जाएगा कि एक हॉर्न की ड्यूरेशन कितनी होगी.
ठीक है, हो गया.
ओके ओके, सो ऑल क्लियर बेटा?
यस सर.
Right, let's go back.
And range of the observer comes to 5.6 nautical miles. Now with 5.6 nautical miles as the radius and belly cotton island light as the center, we can draw a position circle, and this is the position circle of the vessel at 1100 hours. Now we move on to position circle by horizontal angles.
ओके, नाउ बेटा ये जो हॉरिजॉन्टल एंगल वाला कॉन्सेप्ट है, दिस इज स्लाइटली लेंदी. सो डू यू वांट टू कंटिन्यू इट नाउ, बिकॉज हम लोग इसको फिनिश नहीं कर पाएंगे आज के सेशन में. सो बेटर वी विल डू इट इन द नेक्स्ट सेशन.